Deep in Lebanon's Bekaa Valley stands the Temple of Jupiter. Built thousands of years ago, these towering columns represent one of the most celebrated and massive architectural achievements of the entire Roman Empire. But if you look directly beneath those columns, you find a foundation that doesn't match the Roman architecture above it. This lower layer, known as the Trilithon, is built from rough-hewn, tightly fitted megaliths that look entirely different from the temple they support. Curious, the physical reality of these three foundation blocks is difficult to reconcile with traditional tools. Each single stone in the Trilithon is 62 feet long, 14 feet high, and weighs approximately 900 metric tons. This chart shows the mechanical problem with attributing these stones to Rome. The absolute maximum lifting capacity of the most advanced pulley cranes available to the Roman Empire tops out at 60 tons. They would have needed a system 15 times stronger than their best engineering allowed just to lift one Trilithon block off the ground. Roman administrators were obsessive record keepers. They meticulously documented their tax collections, their troop movements, and the exact costs of their bridges and minor buildings. Yet across the entire Roman historical record, there is no mention of quarrying, moving, or lifting these 900-ton megablocks. To lift heavy stone, Roman engineers drilled specific cavities called Lewis holes into the rock, allowing them to insert metal clamps attached to crane ropes. You can find these holes on Roman construction sites everywhere. The Trilithon blocks, however, are completely smooth. They lack any lifting points or anchor holes whatsoever. The Roman records are silent. Their machinery was insufficient, and their standard lifting techniques were never applied here. This leaves us with a physical paradox, a foundation that required engineering far beyond the known limits of the civilization that eventually built on top of it. Mainstream archaeology operates on the assumption that ancient builders shaped their monoliths using primitive, manual tools, specifically copper chisels and stone hammers pounding away at the rock for decades. Independent metallurgical and structural analyses by Russian researchers have complicated that timeline. When they examined the D-joints between these colossal foundation stones, they found the gaps were accurate to fractions of a millimeter. The stones are seated so perfectly that you cannot slide a razor blade between 900-ton blocks. Across the surfaces of these massive stones, researchers documented perfectly parallel striations running 10 feet in length. The spacing between each groove is microscopically consistent, lacking the erratic, uneven impacts expected from a human swinging a hammer. These specific surface markings share a striking similarity to the footprint left behind by modern, high-speed industrial mining equipment. When high-torque rotary machines chew through solid rock today, they leave the exact same evenly spaced, parallel channels found at Baalbek. Inside those microscopic cuts, researchers detected trace evidence of iron oxidation, or rust. This indicates that whatever cut through the stone may have been a metallic tool that degraded and shed iron particles directly into the rock face. When we combine sub-millimeter precision with these parallel striations and metallic residue, the forensic evidence starts to look less like manual labor and more like the product of high-speed machining. The anomalies extend far beyond the limestone foundation. Scattered across the Baalbek ruins are roughly 200 pillars made of a highly specific material, pink rose granite. Roman columns were typically built by stacking smaller, cylindrical stone segments on top of each other. These granite pillars at Baalbek are carved from solid, single pieces of stone, each weighing up to 60 tons. This math tracks the origin of that specific pink stone. The nearest geological source for rose granite is the ancient quarry system in Aswan, Egypt. That requires transporting 260-ton solid granite monoliths, a distance of 700 miles. Reaching the Lebanese coast is only the first step. To get from the Mediterranean Sea inland to the Baalbek site, every single 60-ton pillar had to be dragged up and over the Lebanese mountain range, navigating rugged passes at an average elevation of 8,200 feet. Once the granite arrived, it had to be finished. Granite is exceptionally hard. To achieve the smooth, highly polished circular finish seen on these pillars, you need diamond-tipped machining tools. That technology did not exist on a large industrial scale until the late 19th century. Moving and machining these solid granite pillars would have required a continent-spanning logistical supply chain that challenges our current understanding of ancient capabilities. To see where this project began, we have to look 1 mile away from the temple complex, directly into the original limestone quarry. Lying exposed in the dirt is an unfinished block locals call the Stone of the Pregnant Woman. It is 68 feet long and weighs an estimated 1,200 tons. In 2014, a German archaeological team digging beneath this block found something even heavier. Buried directly underneath it is a monolith they named the Forgotten Stone. It weighs a staggering 10,650 tons. It is the single largest stone ever carved by human hands. Both of these massive blocks are still physically attached to the bedrock at their base. The quarry workers didn't slowly abandon this project over generations. The cuts stop mid-extraction, as if the entire operation was interrupted while in full motion. The distinct mechanized tool marks found deep in this quarry are not isolated to Lebanon. We find the exact same unexplained high-speed striations carved into the prehistoric layers of Petra, Jordan. Halfway across the globe at the Yangshan Quarry in China, researchers have documented the same cutting patterns on massive abandoned megaliths. The presence of these unfinished giants, the identical machine marks across continents, and the sheer scale of the engineering suggests a global phenomenon. Whatever project was underway at Baalbek didn't slowly fade into history. It stopped abruptly, leaving later empires like Rome to build their own legacy on top of a foundation they could neither move nor replicate.